Well, then the next stream class, byte stream class that I want to cover, since we're kind of going through all of the critical byte streams that I think are worth knowing about so that you know that they exist. The next big one is a sequence input stream. And so you might not find the case that you use these often, but it's good just to know about these, because there's certainly times where, and I know that there seems like there's a lot of different byte streams, and there'll be what feels like a lot of different character streams, but they all have a very specific purpose. So just doing a quick overview will let you know what exists. And so as you start building your applications out, you'll be able to make a decision of which stream you should select for getting data in and out of your application. That's the goal here with this unit. So here for the sequence input stream, I'd like to do just a quick introduction on what sequence input streams are. I'm going to show the class declaration. I'm going to show you the constructor, the methods, and examples. So for the sequence input stream in Java, it's a single input stream file that, it's a single input stream, not necessarily a file, but probably commonly a file is going to be the input stream, is a combination of two or more input streams, or likely files, together in a particular order. So it allows us to read data from two or more input streams sequentially, which means one after the other. So that's what we mean by sequence input stream. So the sequence input stream begins to read data from a particular order of input streams. It first reads data in bytes from the first stream. So again, this is a byte stream in that sequence, and then all the data from the second stream in that sequence, then all the data from the third stream, and so on and so on. So when the end of one stream is reached, then that file is closed, and then the next data comes from the next input stream that's fed into it, that when you initially construct it. So the process continues until the end of the file is reached on the last of the contained input streams. Thus, the connection of two or more files into a single file is called the concatenation of files and can be achieved by a sequence input stream class. So this allows us to have one stream that allows us to order in multiple input streams together. So let's take a look at this class declaration. So the sequence input stream class extends the input stream class, and it implements closable, auto-closable interfaces. And so your basic general declaration of that would be public class sequence input stream, which extends your input stream, and then implements your interfaces closable and auto-closable. And again, a sequence input stream has been part of the Java since Java 1, and you can find in the java.io sequence input stream package. So if you have to import it, that's exactly all of these are going to be in the IO package, and clearly they'll import them by class name. Okay, let's look at the constructor for sequence input stream. There are two constructors that are different from any of the other input streams that we've seen, and that's because this allows us to concatenate multiple input streams together. So the first constructor is sequence input stream, and then it takes in two parameters, which are two different input streams. So the constructor creates a new sequence input stream object that takes two input stream objects and as arguments and combines them to create a single input stream. Now it's important to note that since sequence input stream itself is a input stream, you can concat a sequence input stream on top of another sequence input stream. Now for this example, just as a code example here, suppose we create two new file input streams here, where we're going to feed in the file path of, let's say, text1 and text2. And so now we have two references of file input streams. So we have file 1 and file 2. If I want to instantiate a new sequence input stream, I would just go ahead and pass in those two references as such. So file 1, and then we would read everything from file 1. And then after file 1 was done, we would then read everything from file 2. From our file, let's say file 3, our file input stream value here. And so here, let me just illustrate what this might look like with a quick visualization. So if we had file 1 and file 2, the concatenation of these two are now inside of file 3, right? That variable. And as we call that read operation into our program, it'll be able to read all the data from both those files. And so the second constructor, recall there's a second constructor. We can also create a new sequence input stream that takes an enumeration type of input streams as an argument and read the data of the enumeration whose type is input stream. So an enumeration type is effectively something like a list, right? Something we can enumerate across. So if we have a list of input streams, then we could just give that list of input streams to create a sequence input stream. And so in addition to all the methods that are inherited from the input stream class and the sequence input stream class, it also defines some useful methods. Sequence input stream itself has useful methods. We'll just take a look at some of them, right? Since they're kind of novel. We have an available method, and so this method returns the actual number of bytes that can be read or skipped over from the current underlying input stream without blocking by the next invocation of the method. We have a close, which is pretty similar. Always make sure that you close your input streams and release any system resources associated with that stream. We have the read method. That's what we're going to use to be able to read the next byte of data from the underlying input stream. And again, this is a byte stream. And then we can also do read, where we pass in a byte array, and then we pass in an offset value and a number of byte values, which are represented as n and m. And so that method just reads up to m bytes of data from the underlying input stream, starting at the array of n as the index. And just like all the other IO stream classes, it throws an IO exception. So if you use any of these methods, if you use this class at all, recall you either have to throw an IO exception or you have to define a try-catch block. Okay, let's look at some actual sample code. So suppose we want to create a program here that takes in data of two different files, file 1 and file 2, and displays that data on the console. So let's take a look at the source code. I have the source code on the slide here, but I prefer to use my IntelliJ. So let's go to the sequence input stream tester. So here what I'm going to do is I'm going to import my a file input stream. So I can actually build an input stream, and then I'm going to there we go. And then I'm going to import the sequence input stream so I can concatenate multiple file input streams. And then I'm going to also import IO exception. And I'm going to create a new class here. So I can have a main method. I'm just going to have my main method throw the IO exception, so I don't have to kind of muddy my code up using try-catch blocks, since this is just basic sample code. But typically you'd want to, you should preference using the try-catch blocks. Here we're going to have two input files in file 1 and file 2. Let's take a look at those. And actually, I guess I can run this right now so we can look at what the output's going to be. But also let me go ahead and open this in file 1 and in file 2. So in file 1 is going to be welcome to Java programming. In file 2 is going to be, this is an example of Java sequence input stream class. So I'm going to load those two. I'm going to attach two different file input streams to those two different files. And then I'm going to create a sequence input stream where I pass in file 1 and file 2. And now I'm going to create a sequence input stream that I'm going to call file 3. And then here, I'm going to create a loop control variable. And so I'm going to set to my loop control variable a read from our sequence input stream. And so long as that value I, which I'm overriding with this read, is not -1, because remember, -1 represents an end of file, an end of the stream, then I will go ahead and perform this while loop where I'll take that I value, that byte, and I'll cast it into a character, and then I'll display that out using system.out.print. And after I do get a -1, which is my end of file, then I'll just close everything out. I'll close my file out and then close file 3, file 2, and file 1. And so I've already run this code, and we could see that what gets displayed here is exactly the contents from both those files. Welcome to Java programming. This is an example of Java sequence input stream class. So it allowed me to go ahead and concatenate those two input streams as if it were one. Okay, let's look at another example. So let's take an example program where we concatenate, buffer, and display the data of two independent files. Okay, so let me go back into IntelliJ. I guess before I do that, let me jump. And so, yes, I have my source code on the slide. This is where it's at, but I'm also going to open up IntelliJ here. So let me go to, let's see, sequence input stream 2. Here we go. So what I'm going to do here is we are going to play around with buffered, right? We've looked at buffered in the past. So I'm going to import the buffered input stream. I'm going to import the buffered output stream. I'm going to import the file input stream. I'm going to import the IO exception so I can just have my main method throw it. And I'm going to go ahead and have, I'll import my sequence input stream because that's what we're actually evaluating here. I'll create a class. I can have a main method. My main method is going to throw that IO exception, so I don't have to worry about doing the try catch block right now. Here, I'm going to create two file input streams, and I'm going to use those same files in file 1 and in file 2. So I'm going to build some file input stream instances and save them. Then I'm going to create a new sequence input stream and pass in file 1 and file 2 as those parameters, so I can get a new sequence input stream instance. Then I'm going to create a buffered input stream around my sequence input stream because I want to highlight how useful buffered input streams are. Remember, that's the more efficient way to prevent us from having to do require the OS to do constant reads and writes on a file every time we read a byte at a time. We can instead buffer into our in-memory the contents of the file. So we can do that with a sequence input stream as well. And you can see how sandwiching these two classes together creates much greater efficiency for reading pools of data that we have to import into our application. So here I'm going to create a new buffered input stream around that file through my sequence input stream. And I'm going to create a buffered input stream instance there. Then I'm also going to create a new buffered output stream on our system.out. Now recall the system.out is a print stream instance that's defaults to the keyboard. I mean the monitor, our display. And then I'm going to get a reference to that. Then I'm going to create a loop control variable. I'll continually read off of my buffered input stream until I get a -1. That's the end of the file. And until I get a -1, I'm going to write to my output stream, which is going to be my display, the content that I read, the byte that I read, but I'm going to cast it as a character, as a car, to my console. And then I'm going to close everything up. And if I go ahead and run this, we can see what I'm going to end up displaying to the console is the contents of those two in file 1 and file 2, which has then been concatenated into the sequence input stream and then buffered into the buffered input stream. So probably the most efficient way of loading a large number of files together. Okay, I want to take another look at another sample program where we read the data from two input files and then write it into another file, into another output file. So far, we've only been displaying the contents of our sequence input stream. But what if we wanted to take it and write it to another output stream? Let's take a look at that. And here is our Java code for that. But let's go ahead and open that here inside of IntelliJ. So inside of this application, I'm also going to go ahead and I'm going to import my buffered input and output streams, because when I start concatenating them, I probably want to buffer as well, right? I'm going to go ahead and import my file input and output stream so that I can actually open and write to files, right? I can't do that since without having file input and output stream. I'm going to import IO exception, so I can just throw an IO exception for my main method. Of course, I'm going to import the sequence input stream because that's what we've been talking about for this presentation. So I'm going to create a class that has a main method that throws IO exceptions, so I don't have to do try catch stuff. Here, I'm going to open up in file 1 and in file 2, right? The two in files we've been looking at as file input streams. Then I'm going to create a file output stream that's going to be outfile.txt, and that I'm going to make sure does not exist. So let me delete that. Yep, go ahead and delete that. So out file does not exist. We're going to create it when we run this application. Perfect. Okay, then I'm going to create a sequence input stream with those two file input streams that I have references of. So this one and this one. And we're going to create file 3, which is going to be our sequence input stream. Then I'm going to use file 3 to build a buffered input stream. And then I'm also going to create a buffered output stream around this file object stream here that we created that's going to be outfile.txt. Then I'm going to create a loop control variable I. I'm going to read a byte at a time. So until that byte is a -1 that represents an end of value, I'm going to write to my byte output stream, which is now not going to a console or going to our monitor, but it's going to a file that's going to be outfile.txt. And then once I'm done that, I'm going to close all my resources. And let's go ahead and run that. And we will see here, all of a sudden, I will go ahead and produce this outfile.txt. I see that I've successfully written based off of this system.out.print right here. And if I open this up, I can see, yep, the contents of this file is everything that was inside of in file 1 and in file 2. Excellent. And so the last example I want to show you using the sequence input stream is the other type of constructor. I did say there was 2 different constructors. One used enumeration. So let's try to read 2 files using enumeration. So again, I'll have the ability to do that here in this example code, but I'm going to jump over into IntelliJ so we can actually run this application. So here, and I'll start to clean these others up. Okay, so here I'm going to import my file input stream. I'm going to import IO exception. I'm going to import my sequence input stream. I'm going to import enumeration, right? Because I need to be able to pass a data type of enumeration into the second constructor. And for purposes of defining it in forms of something that's list-like, I'll import vector. And here I'll create a new class, a sequence input stream tester 4. This is the 4th example we're looking at. It's going to have a main method that throws an IO exception. Here to illustrate how we can have a list of things, I'm actually going to have 4 different in-file imports. So I'm going to have, let's take a look at what they are. So in file 1, 2, 3, 4. So the first one is welcome to Java programming. The second is this is an example of Java's sequence input stream class. The third is going to be hello world, and the fourth is going to be buy now. So we're gonna create instances of those 4. We're gonna grab input streams on those 4 different files. Then we're gonna create just effectively a collection type, a vector. I'm going to be able to add each of those file input streams into our list, into our vector. And then I'm going to get from the vector, recall that many of our collections data type when we went through unit 2 has a method called elements. And so that creates an enumeration object that we can save as an enumeration type. And so since that's an enumeration type now, I can pass that to this constructor for our sequence input stream that we'll call sequence input stream. And then we'll do the same thing we're doing before. We'll create a loop control variable for an int so that we can read effectively our byte data into it. That's what returns back an integer that represents a value between 0 to 255. So here, until the value is -1, which is end of file, we will, inside of our while loop, read the character. We'll read it as an int, but cast it as a character. And then once we're done that, we close up all of our resources. So let me run this code, and you'll see that we'll be able to load all 4 of those files in and read them inside of our sequence input stream. So welcome to Java programming. This is an example of Java sequence, a sequence input stream class. Hello world, buy now. Excellent. And that's just a quick example of the sequence input stream that allows us to start concatenating multiple streams together. Does anyone have any questions about that? I mean, at this point, we've covered, I think, input streams and output streams well enough that we're just kind of glossing over what makes each of these unique. And I think just the repetition of going through the same thing helps give you a strong foundational understanding of how these input and output streams work in terms of getting data into our Java application and exporting it back out. And it allows us to be kind of agnostic to what is feeding into the stream or what's the sink is on the other side of it. We can kind of abstract it away to just having streams in and streams out.